to what I would consider a brief introduction to R, mostly focusing on histograms. So if you're just logging onto R for the first time, there's a lot of data sets that are built into R, but you need to load them. So if you type library data sets, this will call all the data sets that are in R into your library. And one of the data sets I really like, and you'll see me use throughout a lot of tutorials, is iris. So iris is this data set of 150 irises that are 3 different species with the measurements of sepal length, sepal width, petal width, and species. So if you type in head of iris, what it's going to do is it's going to print out the first few rows. So you'll see like, okay, for flower 1, here's its sepal length, sepal width, and its species, right? The species are Setosa, versicolor, and, oh gosh, what's the third? Setosa, versicolor, and virginica. There we go. I can also type STR of iris. That'll give me the structure. So I've got numbers, and then species is a qualitative value. And what I want to do is I want to show you some things I can calculate with just a few simple commands in R. So the first one's going to be min, M-I-N. I can use minimum to find the lowest data value in a group. So I could find the minimum sepal length, which would be 4.3, or I could find the minimum petal width. So you type in your data set and then a $ to get into that data set, and then it should automatically pop up with all your possible options. Note, if I pick the minimum species, it's not meaningful because it's qualitative data. You wouldn't want to do that, but I could totally pick the minimum sepal width, right? And see what that does too. If there's a min, you bet there's also got to be a max. Again, only for quantitative data. If you ever want to know a little bit more about a function, you could type in question mark and then that function, and it would tell you all about it. It gets a little into the weeds, like a lot in the weeds. There's a lot more functionality than what I'm going to do with max and min. So let's find our maximum of sepal length, and that's 7.9. So we have our minimum and our maximum. I can also find the mean. I can find the mean of the iris sepal lengths. That mean, that's our middle value that marks our 50th percentile of data. And if it's got a mean, then it's definitely got a standard deviation. You just type SD. SD stands for standard deviation. And if I type a hashtag, #, octothorpe, whatever you like to call it, that comments out my data. So I could say SD is standard deviation. I like to keep lots of notes, probably too many notes, but it has a standard deviation of 0.82. Now I want to look specifically at sepal length and width, and what we're going to do is we're going to make histograms of those data. For quantitative data, if we're looking at it on its own, you typically want to use a histogram. When we're comparing two sets of quantitative data, that's when you do a regression analysis, which is the topic of another video. So to find a histogram, a good thing to do would just be to start typing the code you think you want. And oh, look, hist computes a histogram, right? Let me do that again so we can look at it. So hist, oops, I didn't mean to click on it. Not host. Hist. Okay, so the generic function hist computes a histogram of the given data value. So I could make a histogram of the data for sepal length. And here it is. It's absolutely beautiful. It's actually kind of gray. Let's fix that. Let's change it to something much more iris appropriate. When I think of irises, I think of purple. So to change the color, you do COL equals purple, right? And if I want to know all the things I can do in histogram, again, I could do question mark hist. So let's explore a little bit. Okay, so I put in some data value. Probability is not, it's a frequency distribution. If you look at our data set, that's a frequency distribution, but I could change it to a probability distribution by writing probability equals true. There's all these different things we can pipe in. So frequency, if it's true, it's a frequency distribution. Otherwise, it's a probability distribution. I could do my X label, Y label, and main, so I could give it a title. I could not draw the axes. I could give it different labels. Additionally draws labels on top of R. Labels is false. I wonder what happens if labels is true. We'll do that in a minute. But what I want to focus on are giving us our X, our main, and our X labels and our Y labels. So here's my histogram. But I might do labels. Interesting. Okay, so here's our histogram. Control Enter to run it. I'm going to give it a main title, lowercase main, and you have to use quotation marks for the title. So I'm going to do histogram of sepal length Now I've changed the title. My X label, I'm just going to make that sepal length. And just this getting really wrong, I could do an enter and run it down here and it would still work as long as it's indented. Sepal length, Y label. I'm going to leave the Y label as is, but to change the Y label, you just type Y lab. What's labels do? What happens if I type labels equals true? What's that going to do? Oh, so labels equals true gives us the sum, right? This is 31, 30, 27. I could also change it to a probability distribution. So probability, so instead of a frequency distribution, we take the frequency that it occurs divided by 150 because that's no total number of flowers in this data set. Let's see what that looks like. And then it changes it to the probability as well. So you can practice, you can make histograms of other things as well. You could take a look at sepal width. You could take a look at petal length or width, right? If you type in iris, these are all different data sets you could play around making a histogram with. One thing I wanted to show you real quick though, and this is going off a little bit, is plot and what happens when we plot data that shouldn't be plotted. So for example, if I plot iris sepal length, this doesn't tell me much. Because what this is this is the index. So my data set is 150 flowers, right? This data is plotting just the heights of the first 50 and the lengths, the sepal lengths, and then the lengths of the next 50, and then the lengths of the following 50. And each of these are a different species. So in our next video, what I want to do is I want to break up these data sets by species so we can compare them and take a look at them using graphs and bar plots.